general ventilation. Now, when we talk about ventilation for controlling contamination, is it possible or is it viable to achieve close to zero contamination? It doesn't become viable. Cost-wise, it's going to be too phenomenal. So what we do is ventilation, we try and take care of the three aspects of pollution which we want to control. One is general ventilation, which would be heat control and spot cooling. When the other is dilution ventilation, we reduce the concentration of pollution by supply of cleaner air and diluting the number of polluting particles in the air. And then we have an exhaust extraction system. Now, generally when we calculate the formula for this is Q is the airflow requirement, heat is the amount of heat being generated within a space divided by 1.08 into temperature difference. This temperature difference is the temperature of incoming air into the room minus the room temperature, or rather the other way around, so that that amount of heat can be removed by this air, gaining in temperature by TD. So we are able to control the temperature condition of the room. In any ventilation, we'll have dilution ventilation and local exhaust arrangement. Local exhaust would be contamination. Dilution ventilation, as we just talked about, is to dilute the pollution levels. And we will try and maintain the pressure levels with respect to ambient and adjoining spaces. We have other methods of controlling contamination. When the contamination sources are not stationary, we will use dilution. Multiple scattered sources of contamination, again, we can only do that by dilution ventilation. But if the source is a single source or few sources which are fixed, then we can have an exhaust arrangement specifically for removing the contamination being generated by the source. Dilution ventilation will not really work when you have a large volume of contaminants from point sources, high toxicity in the released contaminants, human occupancy close to the source, so breathing contaminant before dilution, or human exposure to contaminant is variable and not predictable. So in such cases, we have to have specific arrangements to reduce the pollutions. Now we come to the kitchen area. Now that was general ventilation. I hope that's clear to most of the people. Most of you must be knowing that in any case, but that was just a sort of reminder process. Now we have one thing which is very, very important is in any commercial space, kitchen is one of the most intensive energy user for its area. So per square feet area, it uses, I would say, the maximum energy for any commercial complex or commercial area. So it's a very, very important aspect where we have to take real care. And as we go along, you will find how we can reach a point to economize this area and take care of the ventilation requirements. Before I start on this totally, I would like to just bring to a point that any questions you have on specific things on a particular slide, please put it up. We'll try and answer it as we go along rather than at the end, because by that time, I think most of the people would be a lot covered by the topic so that you'll keep forgetting the questions otherwise. Please go ahead and ask me the question at any time. Make it an interactive session. I have no issues about being able to control that. Okay. Purpose of the ventilation is obviously provide some comfort, fresh air, replenish oxygen, condition the air for people's safety. Now we capture and remove the effluents. These effluents which are being generated in kitchens will be having carbon monoxide, carbon dioxide, NOx during gas cooking, etc., which we have to remove. The effluents in the gas, liquid, solid form are produced during cooking. These also have to be removed. 50 to 90% of energy is released in the form of a thermal plume. Whenever there is a cooking going on the cooking utensil, there is a certain amount of smoke, grease being released from the food, which rises up as a thermal plume, and the plume actually contains all the effluents. We have to also consider that there would be radiant heating, and which, if we can provide some sort of an arrangement to take care of the people or protect them from radiant heating, and they make them feel a little more comfortable. The points that we consider: smoke extraction, heat contaminant removal, grease effluent removal, fresh air replenishment, because there's fire around, oxygen is being burned, so we need to replenish the oxygen levels. The comfort of the occupants is important. They are, after all, cooking your food, and if they are not very comfortable, there are human aspects which can create a problem. Even sweating and other things can create a problem with the food. Fire protection is definitely a very, very important aspect. So I will not be touching too much about fire protection. I'll be concentrating more on the ventilation side. Now, refrigeration for storage is an area which needs to be considered. Then cleaning of the exhaust air. The exhaust air per se, just like that, cannot be put into the atmosphere. There are codes and standards for it. There are norms stipulated by the government that you cannot have more than this contamination level being clearly removed into the open atmosphere. So we need to clean the exhaust air also. The data requirement that we have: what is the workload of the kitchen, the layout and the shape of the kitchen, sizes and types of appliances being used, type of cooking being handled, number of staff in the kitchen, equipment loads, lighting loads, and other areas of load coming in, including steam being generated or heat being generated at specific points. So these are the data which we will use to arrive at how the ventilation system is to operate. Design consideration: one is cooling to cater to heat from appliances in humans, make up air for pressurization and oxygen replenishment, and exhaust to remove the heat and effluents. Smoke is generated while cooking. We all know that contains effluents, cooking fats, grease, contains unburned fuels, can cause breathing difficulties, can be quite irritating, even fatal from the carbon monoxide from improper burning of fuels. So these are the issues which we have to take into account. There is a thermal convective flow from cooking appliances, radiation heat from the appliances, food fuel generated effluents with convective flow, smoke flow from cooking appliances. Okay, now one of the things which is very, very important is an odor control. Kitchens would, commercial kitchens, normally we are just to dining spaces. So we have to ensure there is a negative pressure in the kitchen, which will eliminate odor from kitchen to dining area and would also cool the kitchen using dining space exhaust air which gets pulled drawn into the kitchen while exhausting the kitchen air. We ensure chance of exhaust air entering back to the dining area, make it non-existent so that there is no question of cooking of the food being creating a odor into the dining areas. There is another challenge area which is very, very important. Nowadays, we have a lot of open kitchens in a lot of dining areas where special care has to be taken to ensure that no odor from the cooked items are reaching the customers or clients sitting in the dining area. Here, the requirements become slightly more stringent and higher. We have to ensure that exhaust air does not cause inconvenience to others. What we need to take into account: the cooking factor, the hood factors, makeup air factor, and the design process. These are the areas which we'll be covering now. Now let's consider, before we go into those areas, heated plume will rise up vertically, entrains additional air and grows in size, but the velocity and temperature will reduce. If surface parallel to plume center wall backplate, the plume would be drawn towards the surface. This is known as a Coanda effect. So if you have a situation of a backplate which actually draws the hot air towards it, so it makes it easier for the plume to be captured in the hood, which we are putting over it. Now the hood size and the location such that the plume flows in without spillage. Now we do not want this plume to be spilling out of the hood, and that is why we are maintaining it in such a way the design has to be perfect, the exhaust air arrangement have to be perfect, so that the entire plume is captured and contained within the hood and exhausted out. So only if the sizing is proper, the capture velocity will have a relevance, but the size is proper, the entire plume will go into the hood, and if the exhaust CFM is proper, then no plume will flow out from the hood. These are the two words which become most important as far as kitchen ventilation is concerned. One is capture and contain. Capture the entire plume, entire pollutant into the hood by having the hood size in such a way that, and having the air flows in such a way that none of the smoke is going out of the hood. And the other aspect which is very important is contain the entire smoke and the pollutant within the hood and not allow it to move around in the kitchen. So these are the two aspects which we have to take care. Which this is something we have covered. Okay. Now there are different appliances duty. This is when we talk about what we need to have as a requirement. We need to know what is going to be cooked at a particular kitchen so that we can decide. Why it's important is for light cooking, which is around 200 degrees centigrade, let's say ovens, steamers, cheese melters, a 50 feet per minute velocity in the hood is normally sufficient. Well, as we go on with a higher temperature, that extra heavy appliances where we are using solid fuels like wood, charcoal, briquettes to heat, here we need velocities to the high level of 185 feet per minute to be able to contain the bloom within the hood. So this is something which is various areas we must know. We have had one experience where I was not told what is the requirement, but they were going to do, they started making Chinese food, and where they were using those, they put those noodles in water and then they pick it out of the water straight off and throw it into huge vessels containing oil. So it actually gives out a sudden burst of steam and affluent around. So unless the, knowing fully well what is required to be done, you have to have the food and the velocities decided accordingly. These are the different standards. I don't think we need to go into details. Medium duty, heavy duty, which we have already just talked about. Where we need high efficiency grease filtration, optional grease control where it's very high, so that we do not have. Now, we have different types of hoods. We will go into the type of hoods, but just for the idea that depending on the equipment duty, a wall-mounted canopy can have from 660 feet per minute velocity or 660 CFM per linear meter of hood to 1800 CFM per linear meter of hood. CMH, sorry. Now, there are single island, double island, eyebrow type, back shelf type, passover type, different types of hood, which we'll go into detailing now. When you have talking about food, spaghetti, when it is cooked in electric or in gas, requires different levels of airflow requirements. Similarly, for all the items, so electric cooking is slower, it requires lesser CFM, whereas in gas, when you cook, the heat is much higher and you have to have better airflows to exhaust. Any system will have a hood. It will have grease baffle filters. Ducting will be there. Door unit will be there. Then you have the air cleaning arrangement or the exhaust air cleaning arrangement using an electrostatic precipitator, scrubber, or a mint washer, mist washer, where you wash the air to clean it off the pollutants before releasing it to the atmosphere. We have a stack, we have a cowl for exhausting the air after the blower, and then you have the fresh air supply system for the kitchen. We have two different types of hood. Type 1 hood is used for removing grease and smoke, used for all cooking appliances. Type 2 is basically without any removal of grease and smoke, but steam, vapor, heat, and odor such as dishwashers, steam using tables, etc., have to be taken out of type 2 hoods. Styles of type of hoods. Wall-mounted canopy is used for all types of cooking equipment. This is located against a wall. Single island canopy is used. It's like an island configuration, center of the room where you'll have a canopy. You don't have a wall next to it. Double island canopy is where you have two rows of cooking equipment mounted back to back, and you have a common canopy over both the rows to take care of the exhaust. Back shelf A proximity type is for counter height equipment typically located against a wall, but could be freestanding also, but we'll have a back sheet which is provided, which will take care of it'll act like the wall. Like eyebrow type, which is for ovens where you are pulling out the drawers or, to take it out, you have an eyebrow means extended hood and the exhaust is from the front to take care of the open drawer for taking out your, or open area to taking out the heated items. There is a passover type, which again, let's just go through the drawings, you'll figure this out now. This is the wall mounted canopy which we're talking about. This is mounted against a wall with the kitchen equipment, and this is the back shelf type where you have a covered area at the back side with a sheet metal created wall, so that this can be freestanding but will work like a wall. Why a wall is important is, like we said, that Coanda effect. If you have something behind, the smoke has a tendency to go towards that, and therefore it remains smaller and can be captured by the. So we'll have the smoke details also. We have photographs of that. When there is a passover, which will allow the smoke, whatever is there, to be pulled over to the side and taken out. So this is known as a passover type hood. This, of course, is a single island canopy where you have one row of heaters, and it's a freestanding, free hanging canopy on top. You have the back shelf type where you have a shelf at the back, and then you have eyebrow type. If you see it in a section, this is how the wall canopy is, where it's clearly defined here against the wall, and you have, this is what is known as the overhang of the hood. When the fume rises from here, it rises in. Let's just take a situation of the fume from here rises and grows. So once it grows, we need a overhang of the canopy to take care of the fume which is coming out from the cooking appliances. So this is how we have a design arrangement requirement for this. Single island hood, double island hood, these are all sections of the same. This is how the equipment is mounted, and you have, extension on both sides, overhangs on both sides. Similarly, you have an overhang here and an overhang here for the equipment. And sometimes you can have a partition in between here, which helps in capturing the fume better. The minimum overhang. Now there are two types of hoods again on this. One is the listed type and the unlisted type. What we are talking about is all unlisted. There are a lot of standards being created now by the UL has listed certain type of hoods, which they have specified requires lesser amount of airflow and which can be used to reduce the energy consumption for exhausting. With a wall-mounted canopy, we need at the ends minimum 150 and in the front 150. That means 6 inches of overhang in the ends, both ends, and 6 inches of overhang in the front. Backside is in any case a wall, right? For the single island, you require 150 all round. Double island also same way, 150 all round. These are the minimum levels. Eyebrow is again 150 overhang. Back shelf type is again 150 overhang. Passover is 150 overhang. So one of the things which is most important is you must remember that you must have overhang beyond the cooking area by at least 6 inches for your hoods. But be sure this will depend on a particular height of the hood. Now, if the height of the hood is higher, you will need a bigger overhang because the plume size is going to go on increasing beyond that point, and there you will have to have a higher overhang to take care of the hood. These are actual pictures. Normal view is given here. When the doors are open here for the oven, the smoke starts coming out. Unless we have this overhanging hood, which will take care of this. This is the eyebrow type hood. The smoke will go out. The smoke which is going to create a problem outside. So these are things which you have to take care of it when you are designing. Same thing which we are talking about is with a hood front overhang of 6 inches, we need without rear seal, we'll need 5100 CFM. With rear seal, which is the wall or the backside, we will need this much of a lesser airflow requirement. Whereas with a higher front overhang, again we need lesser airflow requirement. So depending on whether you want to reduce your airflow or whether you want to have a lesser overhang, you have to decide and work out on that basis of these airflow requirements for a, this is of course for a broiler. You could have for different areas, different CFMs requirements, which can be taken into account of this. Same thing for the canopy hood, wall canopy, hood of the broiler. Now here is where we're talking about is the height of the hood. From the cooking area, if the height reduces, like I was talking to you about, the airflow requirement reduces. If the height increases, you have to have a higher airflow requirement and maybe even a higher overhang. Now, another aspect which is there is when you have the hood on top, if you have a side panel on the hood, the airflow requirement comes down. So if you have no side panels, you require 3300. If you have a 1 feet by 1 feet angular at 45 degrees, you need 3100. And similarly, as you have 2 feet by 2 feet or 3 feet by 3 feet, the airflow requirement reduces because it provides you the same wall effect on the sides also. So you will need lesser airflow. Now comes the.
Sir, can you, sir,
Yeah.
excuse me, can you please repeat once this slide?
Yeah. Okay, this one.
Yeah.
Okay. Now we're talking about a side, this thing, a plate. Now, in any wall canopy, what did you have? You had the wall at the back, right? Okay. Now,
Okay.
but if you have a side plate like this on the hood, which is providing a wall effect on the side also, the Coanda effect also takes care of there. So if it is 1 feet by 1 feet at 45 degrees, then the reduction is from here to here CFM. Okay.
Okay.
Now, if
Okay.
you use
Okay.
a 3 feet by 3 feet, that means if this is 3 feet
Okay.
and this is 3 feet,
Acha. 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 Okay. Okay. I
then
understand.
what happens is this is the amount of reduction in the airflow requirement.
Okay.
Okay,
Okay. 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 Okay.
that's
Understood.
clear.
Thank you.
Yeah. Now, with low airflow, you have a spillage, which the smoke starts coming out from under the hood. So this is where we have the problem of not being able to contain what we had actually got it to come inside, but we are unable to contain it and it starts flowing out. This is what happens with a lesser airflow. Whereas if the airflow is proper, then the smoke rises like this, it fills up the hood, but it doesn't go out of the hood. It doesn't go out of the hood. It stays within the hood and gets taken away by the hood. Exhaust arrangement itself. So low airflow and proper capture airflow, this is the important aspect which has to be taken into account. Okay, now let's just talk about the type 2 hoods. We've been talking about the type 1 hood till now, where it was all with grease and other thing. Here what we do is we have a removable condensate baffle, and where because of the steam which we do, we collect the steam and let it come and drain out from here, so that it doesn't keep falling, dripping on always on the side. So this is what the baffle is provided to ensure that none of those condensation drops back into the space. And the heat and fume hood can be without any baffle, where you're taking out only the heat. Here this is for steam, so that condensate doesn't come down. Now we come to the baffle filters. This is the device for removal of the grease. It has multiple vertical baffles to trap and drain the grease. And it's generally made of stainless steel or aluminum, but mostly stainless steel, I'll put it. Very rarely aluminum is used because it would become much thicker and much bigger in size. Airstream direction changes through the baffles to release the grease particles by centrifugal force. It is removable and cleanable using hot water. This is the basic qualities of the baffle filter which we use for removal of grease. This is how they look like. I'll just show you a section of that as to how the grease is being trapped in these baffle filters. This is what the baffle filter comprises of. You have air which hits here, gets changed in direction and goes out like this. So all the grease is collected here. And since it's all vertical, this section, the grease starts draining out of the filter. And when you have the filter at an angle like this, and the grease is collected in the last point here, starts draining out, and you have a drain pan and remove the grease from there. So none of the grease is falling back into your food being cooked. That is the reason why these baffle filters are very important and are used regularly along with the hoods.
স্যানিটাইজ করো হাতটা তাহলেই হবে গ্যাপে বসতে হবে হ্যান্ড হাইজিন ইজ ইম্পর্টেন্ট
Can you mute, please? Yeah, okay. Now these are the airflow versus the pressure drop. It's a high pressure drop as far as grease filters are concerned because of the change in the direction of flow. So you have the airflow possibilities of collecting what sized filter can take care of what airflow at what pressure. It's available on these charts. You can do your selection and accordingly select your static pressure for the blower, exhaust blower. These pressure drops have to be taken care of by the exhaust blower. See, the important aspect is if you consider that 1.4 inches or 2 inches of air pressure is there, that means this much of negative pressure is there in the exhaust duct. So the exhaust duct has to be very clearly negative pressure. It has to be strong enough to withstand that negative pressure and take care of it. So it's very important. And that is where a minimum gauge of GI sheet or aluminum sheet is to be used for ensuring, or maybe stainless steel sheet is to be used for exhaust ducts. So that has to be catered for. So again, that similar, instead of that chart, this is a thing which gives you an idea of what it is. Anyway, whatever is there, you have to take care of it in your design. Now there are other grease removal devices, which once you have taken it out from the hoods and taken it to the blower, before discharging it to the atmosphere, we use for cleaning of those contaminants from the air, we either use an electrostatic precipitators. I'll explain that to you how it works. You have an ultraviolet destruction system. You can use water mist for scrubbing the air, cleaning the air, because then the pollutions are being removed by the water. You can put it into a water bath. You can bubble the exhaust through a water bath, and the pollution will remain with the water and the air will be relatively clean. Or you can have a dry type scrubber. Dry type, these are wet scrubbers, these are dry type scrubbers. Now, dry type scrubbers are mostly electrostatic precipitators. They're common items.
Sir, I would like to just add to it if you permit,
please, of course.
Yes, sir, actually we have one bio agent that is specialized and has been certified from Environmental Protection Agency worldwide, which cleans the surface instantly. So if you want, I can, yes, be it grease or any hard lubricants or stimulants, it can clean up instantly.
So when you're talking about the hoods or the exhaust duct, right?
Yes. So it will be it is known as BioTab basically. So we are authorized for that. You can search online BioTab, and that is very much effective, sir. And that is food safe also.
See, the safest is the steam which is used or hot water which is used. But of course, your product also could be better than that, using and cleaning. So there are so many products which are available. So I guess we can, your product should be usable.
Okay.
Okay.
Yes, sir.
It's basically something which has to clean the hoods or clean the filters, clean the duct. One of the major problem with grease in the duct and on the hoods is that they can get ignited and cause fire. So it's very, very important that it needs regular cleaning. Whether we use a hot water or whether you use BioTab or whether you use some other item, we have to keep it clean. That's the most important aspect.
Yes, true, sir.
Yeah. Now, we have different varieties of makeup air. When we are exhausting certain amount of air, let's say when we talked about 600 feet per minute, 600 CFM per meter of hood, and you have, let us say, 4 meters of hood, then you have 24 100 CFM of exhaust air. Now you can't draw 2400 exhaust air directly from the dining room area, so you need to put in fresh air into the kitchen area. Ensure that this area is a little less so that negative pressure is maintained, but still you will need to put in fresh air into the room. So what we do is, in the hood itself, we make slot arrangements, or we may have separate arrangements for putting this, for which different flow patterns are going to affect the flow pattern for the plume which is going into the hoods. So that's an area which is very, very important, and how it has to be worked out is again a matter of a lot of detailing, and we must properly do it. When we go, and we'll show you some of the pictures which have been taken of actual experimentation, where we have the plume, how it is impacted due to different varieties of flow of the fresh air has been shown, and accordingly the best possible out of that, or considering the site condition requirements or site issues, we have to take into our designs. Now, when we talk about another area is that anything below 60 degrees Fahrenheit can coagulate the grease on the filters or in the duct. So if outside temperature is very low, like in winter, let us say, we definitely go below 60 degrees Fahrenheit, right? Even in Calcutta, we go to at 45, 40 degrees Fahrenheit. So at that stage, if the duct is running outside, then the grease will get coagulated and deposit onto the duct and will not go out along with the exhaust air. This is where you will need to provide a duct insulation. The temperature difference is that way. So please ensure that you consider this as to what is the ambient temperature through which the exhaust duct is passing, and ensure if insulation is required to insulate the same. I would suggest you should insulate in any case if it is running outside or otherwise also, because it remains very hot, and it can create a problem for people touching it. So an insulation would protect them also, to take care of this problem. These are the different types of airflows, which I was talking about, the fresh air. This is the front face discharge. The hood, the exhaust arrangement is here. You are exhausting air from here. You are supplying fresh air in this. And that fresh air is being thrown out like this. You could have the discharge straight down below. You can have the discharge inside the hood, or you could have the fresh air coming in from the backside like this. And we will go through the details of which out of these works the best and how it impacts the capture and containment of the plume. Now, this is where it comes down straight down. So here, the moment it is like this, it will have a tendency of pulling the smoke out of the hood, and it will spread. So this is one area which we have taken into account. So straight down is not a very good idea. Backside, if you see, because of the air flowing from the backside, the plume gets smaller and goes into the hood. So this actually, because of the Coanda effect which is there, which I was talking about earlier, this airflow continuously downwards is actually having a great impact on improving the flow of the plume into the hood. Throwing it on outside to the side at an angle is also allowing the smoke to be pulled out. Putting it inside, we have a problem. It does not allow the smoke to come out, but what happens is, because it is being put inside, this pushes out the smoke from here and it starts leaking out here. So the capture is fine as far as the smoke is concerned, but the containment goes a little, gets upset because of this airflow. So the plume again goes out, it spills out, which is also to be avoided. And these are actual photographs, right? These are from ASHRAE handbook. These are actual photographs of taken how the smoke gets spilled out. Same thing here. It is inside, it's going to be spilling out. This is one area where you have the airflow from outside separately and you throw it in, but this is with air discharge from four-way diffuser. So if you have a diffuser, it allows the smoke again to come out. This is ideal as far as the containment or capture of the smoke is concerned, but it also has an impact on the burner which is here. So if this is to be used, you have to be very clear that the makeup air is supplied at very, very low velocities from the displacement diffusers on the side. So that is a very good arrangement, but care has to be taken for it to be at a lower velocity, not to impact the flame. This is the same thing given in a colored picture where we have the exhaust, we have the supplies, inside supply, then you have the bottom supply, the side supply, and then outside supply. The kitchen air conditioning. This is something which is being done and it is being taken care of by at good, very, very high quality kitchens. What we do here is we generally go in for a sort of spot cooling for people who are working there, because the air is going to be so heated after it is used that it cannot be used or recirculated back into the air handling unit. So what is done is small quantities of air are supplied over the people working. So suppose if there is a wood here and you have people working here, you could have diffusers provided here which will do the spot cooling, and a small quantity of air supply will keep the people comfortable. Because in any case, the hood is taking care of the heat and the grease, and you have fresh air coming in. Plus, on top of it, you are providing a spot cooling for the people working over there. But this has to be 100% fresh air. That's very important. And it has to be reduced from the amount of fresh air being provided here to ensure the negative pressure. So these aspects have to be taken care in the design. This can be done with spot cooling without much of cost. Of course, in a dry area, you can go comfortably with an air washer. But you have to be very careful that you don't use it in a wet area like in Calcutta. Calcutta, a particular hotel has installed a lot of air washers in their kitchen, and now they have dispensed with it. They have just disconnected it and kept it lying idle, because it makes the air so humid inside the working space that the cooks are unable to work. So that's an area which you have to be careful about. You have to consider that in your design. Conditions, of course, are not going to be the same as you're maintaining the dining area, but yes, somewhat comfortable for the people working. And this, of course, is an area which I spoke about. The flow should be such that it does not disturb the good fresh air and exhaust flow. Ensure that the capture and containment does not get affected because of this. Okay. Evaporative cooling, I've already told you, should be there for good dry climates. This is what we've been talking about. And this ratio of grease to particulate matter will depend on the type of food and the type of cooking. So we have to consider this when we do this. For different areas, we have, everything available, all data is available as to what would be the amount of emissions for different items being cooked under different conditions, different way of cooking. And accordingly, we have to cater to the exhaust arrangement and the filtering arrangement for the same. Different food, different cooking media. So if you're using a Chinese wok, where you have the maximum amount of particulate and some vapor, whereas in a gas broiler hamburger, you have much less at that level. So this is the case which I was talking about, where we do need different type of handling and different type of designing to take care of that. Okay. Now, as far as the NFPA standard is the National Fire Protection Association standard, which is standard 96, it has specified very clearly a minimum velocity of 1500 feet per minute to reduce duct deposition of grease. So for carryover of the grease along with the exhaust air, they have recommended that you must have a velocity higher than 1500 feet per minute. ASHRAE research, however, has proved that no increase in grease deposition below 1500 FPM velocity is noticed. So this is there, but since the NFPA standard is there, which has finally been revised again to mention that the minimum velocity of exhaust air should be 500 feet per minute. But I would still suggest that you go something around 1500 feet per minute velocity and exhaust air, because it does help. Even if there is no grease deposition, at least as far as the particulate matter is concerned, will get carried away because of the air velocity, and the duct will remain relatively cleaner. But with temperature difference between outside and inside, there is distinct deposition of grease, which is what I was talking about. So duct insulation has to be considered wherever there is a difference of temperature, which is quite high. So I would recommend that duct velocities above 2000 feet per minute will cause noise, and less than 1000 FPM ducts may become large and expensive. So stick to 1500 to 1800 FPM velocity for your designing of the exhaust duct. Because we're going to have thicker gauge also sheet used for this, so cost would go up quite a bit. There is one area of economizing that can be done is by working on demand controlled ventilation. So if the demand is not there, you could reduce the blower speed and reduce the airflow. So the duct remaining same, the velocity comes down, but then airflow reduces, the power consumed by the blower reduces, and you economize on the energy consumption. Of course, for economizing, please change over to better cooking appliance with lesser airflow requirements. That will be much better for your system. Ducts can be round or rectangular. Must be grease tight, should be free of traps that can accumulate grease. Never have a sort of dip in the duct and then it goes up again. It will start collecting grease, which can be a fire hazard. So please avoid that. Minimum sheet gauge should be 16 gauge steel or 18 gauge SS. Horizontal duct runs should pitch towards the hood for continuous drainage. The slope should be 2% for runs under 75 feet. For higher runs, refer to local codes for this. NBC specifies this, NFPA specifies this. There are all codes there which have to be taken care of while you're designing this area. And codes are very important here. You have to go through particularly the fire codes which have to be worked. Then turning radius should be minimum 1.5 times of the duct dimension. In turning direction, provide grease traps, clean out access for sharp turning radius wherever you have. Never use turning vanes inside these ducts. Locate fan closest to discharge point to avoid leakage out from discharge duct. Why do we do this? Because we're going to work at a high pressure drop thing, and we cannot allow, or we should not allow, the air which is going out to have leakage of oil till the time that we want it discharged outside. So we will try and locate the fan as close as possible to that, so that the positive pressure, once it is inside the duct, will actually not allow much of leakage, even if the duct is not as leak-proof as possible. What happens in the suction side is, even if there is a little bit of leakage in the duct, because of the negative pressure inside the duct, the leakage of the oil generally will not take place outside. It will get pulled into the inside and taken out. Ensure that your duct is provided for the expansion due to the heat. It will keep on getting heated, increase in length, as well as shrinking once it is cold. So kindly ensure that the expansion which is required, if too much of a straight run is there, some sort of an arrangement for making it wavy or turns to ensure that the provision for expansion is taken care of. Please ensure that the building, whatever is the provision, you have to take the duct beyond the roof, and there is a minimum level. I believe some standards say 2 meters, some standards say 3 meters beyond the roof level. So that has to be taken care of depending on the locality and the standard applicable. Use it accordingly. Type of cooking, depending on that, whether you should have a duct cleaning schedule, you must have a monthly schedule, you have to have a quarterly schedule, semi-annually and annually. This is from NFPA standard. Let's say if you're cooking with solid fuel, you must clean the duct on a monthly basis. High volume cooking, gas char boiler or wok cooking, quarterly. Modern volume, moderate volume semi-annually, and low volume churches, day camps, seasonal business annually. This is something which fire standard specifies. Energy compare. So try and design the hoods for as low air flows as possible, but ensure that your capture and contain is taken care of. Do consider the type of restaurant, do consider the restaurant's menu, and ensure that you are not oversizing. Type of food service and equipment installed, as well as flexibility for future upgrades. Now, equipment installed, try and get people to upgrade their equipment also, so that your discharges from the equipment is lower and lower, which will save you energy conservation on the exhaust arrangement or the kitchen ventilation. These are things which we've already covered. Wall-mounted canopy hoods operate at lower flow rates. Single double island hoods are more sensitive to make up air and cross drafts than wall-mounted hoods, obviously, because open from both sides. Side panels, overhangs allow reduced exhaust rates. Drawing air from adjoining dining space allows reduced makeup air as well as improves kitchen comfort. Demand controlled ventilation, modulate the airflow for specific cooking operation. Evaporation cooling instead of air conditioning. Heat recovery from exhaust, which can be used somewhere else for taking care of the heating requirements. I'll just take an example. Let us consider a small restaurant, a quick service restaurant where this there. Now, with a normal unlisted hood, which we have, which we are talking about, unlisted and listed hood, if you remember. Now, with a 6-inch overhang, the hood front face with 2 deep fryers, fryer drip station, 4-foot griddle, half-size convection oven, and overhang 6 inches. We have the length requirement of the hood, which is about 11.25 feet, whereas the active cooking length is 9 feet. And with something is medium, something is light cooking. So this is the requirement. Now this is what we have got as the input data. We're going to do a check on different ways of handling this. Let's say this is a hood, which is 11.25 feet in width. And of course, standard 4 feet or with the 6 inches overhang in the front side. That will be the hood size. Now, if you work out on a wall mounted canopy, this is the airflow requirements. For an unlisted hood, light duty equipment will be 200, medium duty equipment 300, and so on and so forth for different things, single island canopy hood. Now, depending on what type of hood you have, you can take a certain amount of airflow on this and decide what is the amount of air you're going to use. So, considering this, .5 feet into 250 CFM per square per feet works out to 2375 CFM for a UL listed canopy. Whereas for an unlisted canopy, we have had how much? Now there is an optimization and design that we can do. We can use this into 2 hoods rather than 1 hood, with 1 hood here for this and 1 hood here for this. And leaving this out because this does not need a hood. So considering this, the recommended exhaust rate of 150 CFM per square foot per linear foot, the size of the hood having reduced, as well as the airflow requirement having reduced, this is the type of arrangement then you will have for this and this. So 6.5 feet, and this will be the width of the equipment. Now with the listed design, we will have for this optimized design 375 CFM, 975 CFM. Total would be 1350 CFM requirement. What happens with the reduction? The single unlisted canopy hood, we were getting 3375. Single listed canopy hood, we were getting 2375. And with the custom engineered thing, which we were talking about now, is we are able to save 60% reduction in the airflow, and automatically on power consumption, it's much, much better. So this is one area which you can consider for economizing the energy consumption for the kitchen. As we put it, the entire building design should be integrated. The pressure, all areas of the building will be higher than ambient pressure to avoid infiltration. Food preparation area shall be less than dining area. Dining area shall be less than other areas. This is the entire building configuration that we got to have, because dining areas, again, smell cannot go into the general public area. Similarly, food preparation area, smell cannot go into the dining area. Building, to avoid infiltration of air as well as dust, you got to have a positive pressure in the entire building. The air will isolate the dining and food preparation area from other areas, use separate air systems. Dining areas should not have any perceptible afterwear. Kitchens may not be draft free, but velocities near hoods should be less than or equal to 75 feet per minute. This is important because the velocities near the hoods, that means near the fire, should not be higher than 75 feet per minute to disturb the flame and lose a lot more heat and energy, which doesn't go into cooking because of the disturbing factor of the higher velocity, disturbing the air, fire flow itself, the heat flow itself. Electrostatic precipitator used in the exhaust stream downstream of the hood, and the most common high efficiency design that is there is an ESP. What we do is, with the high voltage ionization particles are collected on the flat electrostatic plates, and only air is allowed to go through. Efficiency may drop as the ionizer section becomes dirty and effective surface area is reduced. Under heavy loading conditions, unit may shut down because of voltage drop. If there's too much of loading, it will drop. This is the view of a electrostatic precipitator. The dirty air comes from the pre-filter. It is charged here by where the ionizer is, where the particle is there, where you have a positive pressure, the positively charged ions will get deposited onto negative plate, and the other way around, the negative particles will get deposited onto the positive plate, and clean air will flow out from here. This is the system of operation of an electrostatic precipitator. This is the actual view of an ESP, where the ionizer is there, and then you have the plates for clean air to get out. UV light is used to chemically convert grease into an inert substance, but adequate exposure time for chemical reaction is required. High intensity UV lamp can be dangerous to human beings. Their eyes can be affected, so it should be shielded from the eyes. Some forms of UV may generate ozone, which is very, very important area. We have to have the exhaust on when UV lights are on. UV lamps need to be replaced periodically because they lose their efficiency. Water mist scrubber or water bath. Passing the effluent through water and traps particulates and condenses grease vapor. Static pressure drops are high. Grease-laden water tends to clog drains. Water hardness a consideration in spray and nozzle system. These are the aspects which have to be taken into account. But this is quite an effective way and an easier way of handling if it can be done, and everywhere. If the wet scrubber is always going to be less maintenance requirement, except for the drain clogging and things like that, which have to be taken care of. Blowers for exhaust. I'm not talking about the blowers for the fresh air, because that's standard air, normal air. You can use any blower. You could use a tube axial fan, but it's noisy. You could use a plug fan, whatever you feel like. There it's not an issue. But where the exhaust happens, if you use fans with, let's say, forward curved, or with the blades which are there, which gets clogged, and the deposition of solid particulate takes place on it, it's very, very tough to keep cleaning these blowers. So best is to use a self-cleaning type blower, which would be ideally an SISW, that is single inlet, single bed centrifugal fan with backward curved impellers and not forward curved impellers. This is an important aspect which has to be taken into account. It has self-cleaning properties. It has higher efficiency. It has a limit load characteristic. It will not get overloaded, and it can work without scroll also. You place it in a housing, which becomes a plug fan or a plenum fan, and which can continue working, and that cleaning becomes much easier once it is done in a housing. So the scroll need not be opened, the impeller need not be taken out. A person can go in and clean it. So that's an important aspect. That is where a backward blower is an important aspect. This is how a kitchen exhaust system can go horribly wrong. This is what will happen when the spillage of the smoke takes place. See what can happen here. This was a kitchen I had gone to where they had complained of this problem. Of course, yeah. This was after we rectified it. See the difference in suction which happened. Even with certain bursts of putting water in the tandoor, which was sudden heavy steam, it was getting sucked out in no time. This system had airflow from the top, fresh air, and we also had this thing available here, the spot cooling. See, this is ideally how it should be working without any spillage at all. Yeah, thank you. Now, if you have any questions.
Thank you very much, sir. That was a wonderful session, actually. And before we move to the questions, sir, we have a quiz. So let us quickly run through the quiz, and then we can take the question answers. So
I'll take a break for a few minutes. Go ahead with that.
that would be efficient for you as well. So we are running the quiz. So for everyone's benefit, this quiz is we organize this during every DL program. So the quiz is live. You can give your answers. There are 5 questions, and we'll be running it for 2 minutes. After 2 minutes, we'll be closing the poll. And whoever is giving the answers for the first with the fastest will be rewarded with a certificate and everything. And also please note that this is only for our members. So non-members who have joined us can also take part, but will not be considered for the evaluations.
Allowed to take part.
Yeah, they are allowed to take part, but they will not be considered for the evaluation.
Can I take part?
Of course. This is anyway, this is said by you. So, so the questions are said by you only. We have 50 seconds have passed, and another 1 minute will be running this. Ten more seconds. After this, we'll be ending the poll. We have already received a lot of answers. Okay, I think that's it. So we're ending the poll now. So this is the result, sir. So quickly, we'll just run through the questions. So this is the first one: is which area of ventilation is used in commercial kitchen ventilation? So, sir, if you would like to give the answer, to disclose the answer, rather.
You give the answer.
So the answer will be all of the above, sir. Which 70% people have answered. The next one is, what does the term C&C in kitchen ventilation depict? So it's capture and contain. I think, sir, if you can clarify the answer, because there are mixed responses that we have received.
Yes, capture and contain.
It's capture and contain, not content and capture. So capture and contain is the right answer for this. Then what is the minimum overhang for an unlisted hood? So the answer for this is again 6 inches. That is one. Yeah. 30% people have given it right answer. What is the minimum gauge of GI ducts for kitchen vent exhaust? So here, so the answer will be 18 gauge.
16 gauge.
16 gauge is the answer.
SS is 18 gauge.
Yeah, SS is 18 gauge, right? So GI it will be 16 gauge. And the last question was which blower is suitable for exhaust, and I think most of them have given it right answer.
Backward curve.
Backward
Yeah,
curve.
that was the last topic covered, so everybody remembers this.
Yeah. Okay, thank you for taking part in this quiz. Now, if anyone is having any question, they can put it in the chat box, or they can one by one unmute themselves and ask the question. If there are any
Seem to be
questions,
any questions, so it's not been a good lecture that we don't have questions, which is something a little.
no, sir. There is another perspective that it was a wonderful session, so everyone has understood everything.
That never normally doesn't happen. So somewhere along the line, maybe people have gone to sleep. Possible. No, but the answers they have given, there's quite a few good answers have come. So, yes, people have
Yeah.
listened to it.
So there is a this. He's asking for a suggestion about kitchen ventilation, kitchen exhaust design books.
Best is to go through the ASHRAE handbook. You'll get a lot of data and information there to be able to design from there.
Okay.
ASHRAE handbook of applications. I think it is probably chapter 19 or I think or chapter 11. I'm not sure. I think chapter 19.
Okay, sir. So one more thing I have, does this ASHRAE standard also are applicable for Indian conditions?
See, we really do not have too many Indian conditions. So, in fact, even in USA, they had different sort of things when they had standards. They had an international mechanical code, and then they had a uniform mechanical code. So this international mechanical code was brought out by California, and they were following that, whereas uniform mechanical code was formed in the eastern part of US. And so generally now they are got more or less aligned, and uniform mechanical code is being used. Similarly, now we have the fire people giving up some codes. Then we have NBC. Then we have NBC has got details given for handling of kitchen exhaust. So those are the codes you can follow. National Building Code is a good code to follow.
Okay. And are this information there in our ASHRAE handbook, sir, regarding kitchen ventilation?
No, it's not there in not there. Because I think ventilation handbook is under updation. This time when it is updated, we'll be having the kitchen ventilation subject again.
Okay, sir. All right. So we are not finding any more questions here. So next, I'd request our Secretary of ASHRAE Kolkata chapter, Shankar Bhattacharya sir, to kindly deliver the vote of thanks and then close the session for all of us. Over to you, Shankar sir. Sir, you are on mute, sir.
Please,
Sir, yeah.
Hello, am I clear now?
Yes, sir.
Yeah.
It's an honor to offer a vote of thanks after the program and that too after Dipak sir's program. So on behalf of ASHRAE Kolkata chapter and on behalf of entire team, I express a very hearty gratitude to our distinguished lecturer, Mr. Dipak sir, for his valuable time with us in today's webinar. Thank you, sir. I'm thankful to the audiences, senior members, members and non-members, faculty and students for joining and attending this interesting and relevant topic of kitchen ventilation in this virtual mode. Thanks to you all. I'm very thankful to our chapter president, Mr. Manish Tiwari, and president-elect, Ms. Nilanjana Mukherjee, for being with us. A special thanks to each of our sponsors for their valuable contributions to the society. Thanks to our program chair, Amitabh Datto, and his team, Mr. Shubhan Bhawik and Mr. Siddharth Majumdar, for providing the technical support, hosting, and making this program a successful one. I would take the privilege that in this program, I request the non-members amongst the participants to come forward and enroll their names with ISHRE and be a part of our society. I'm also requesting the members whose renewal is due to get their renewals done at the earliest and enjoy the uninterrupted services of our society. Stay safe, stay healthy, and stay tuned to ISHRE Kolkata chapter through various social media platforms for the upcoming activities and webinars. We thank you for being with us. Have a great day ahead. Thank you. Thank you, everybody.
Thank you so much, sir. Thank you for the opportunity for hosting this event. And with this, with everyone's permission, I think we can close the evening.
Yeah.
Okay. Thank you. So Siddhartha, we can end the meeting.